uh, 2-3 minutes, then we will start. Okay, so this is basically going to be the summary session for week 7. Okay.
Hello, ma'am.
Huh. Yes.
Ma'am, can you give us the permission to access the PA session that happened in Google Meet?
Mm, okay, so you want access for the recorded version?
Yes, ma'am.
Okay. We will give.
Thank you, ma'am.
Yeah. Is there any other session going parallelly? Why so less? Just
Just now start
this.
finished. Start
Uh,
finished.
Yes, ma'am.
yes, that session is still now going. That's why
No,
someone.
it's over. It's over now.
It's over.
Yes.
Yeah.
Oh,
Okay. So we can see for 2 minutes. Then we will start from 8:10. So that if someone wants to join, then let them join. Then we will start. Okay.
ma'am, hello.
Huh. Yes.
Ma'am, if you take some proper question solving session, uh, some quality questions with a good concept, it will helpful for us because only theory sessions is not that much
Yes,
helpful.
yes, ma'am. Yes,
Uh,
ma'am. Same
okay. So
suggestion.
I
Because,
mean,
be-
you mean
because
for this week? I mean,
because you
week 7.
you are clearing our concept, but we are unable to apply those concepts because TA sessions are not
Okay.
that much good because they are also students. They don't have
Mhm.
that much experience how to teach and teach us. But you guys are quite experienced and have the knowledge how to
Ma'am,
teach.
yes, ma'am. And ma'am, is it possible for you to take the quality questions for all the content, like from week 7 to week 12? Because before week 7, we can mean somehow able to manage, but after
Mhm.
week 7,
Week
it's
seven
very
after
difficult.
after week 5 the problem is starting right now. Week
Yeah,
4
yeah,
तक
yeah, yeah,
4 तक
same.
अच्छा था लेकिन अभी नहीं हो रहा है वो.
Because we have studied till
Okay.
12,
So,
so we can relate.
okay. So you are facing problem with week 5 and 6?
Hmm.
Yeah, ma'am.
Or
After
so?
week
Yes.
five,
Five,
yes.
five onwards, five onwards.
5 onwards. Hmm.
Okay, but in the open session, I solved some problem, na? So, did you join that open session?
Yes, tomorrow's session is good. You have solving doubts,
Yeah. So it
but
was like
but
okay, na?
I
Mm-hmm.
want you to solve uh, some
More questions, I
all
guess.
the questions actually because the concept which is describing in the recorded lectures by the professor are not covering whole entire concept of this chapter of the particular week, and
Okay.
that and the TAs are coming and solving question, but their style of solving is not that much good enough.
Okay,
Okay.
Samrita, I think from week
And
5
if
to
we
till now,
go through,
there is the ambiguity with the schedule, as you know. So some of us were
Yeah, but
with the schedule.
we will, yeah, we are like working on it from week 6. So I guess
Uh,
it's okay from week 6. Correct.
so the some of us missed the thinking that there is a swap in the day something. Some of us missed the
Mhm.
your lectures. So what you asked whether you solved the question and the thing, but some of us followed and some of us couldn't be there. So
Yeah.
that's also one of the
I
our fault was also there.
Okay, so okay, I will definitely solve problems. because it's week 7. Okay, so I will try to do like them parallelly. I mean, I will clear the concept, then parallelly I will solve a problem over the concept. Okay, so for week
Okay,
7,
ma'am.
I am doing this. Yeah, and week 5 and week 6, I will request you just if you were like you guys were not in the open session of week 5 and week 6, then just go through it just once. Then still, if you have doubt, there are revision sessions too, right? Before your quiz too, we will have revision sessions, and then we will cover week 5 and 6 again. So if you want me to solve some problem over this type of concept, then at that time I will cover the some concept and along with some problems. Is it fine? I mean, is it feasible?
Yeah, yeah, yeah.
Yes, ma'am.
Yeah,
Yes,
if
that's fine.
all of you are okay with it, then I will prefer doing this. I mean, today I will solve some examples with the concept parallelly, and in the revision session of week 5 and 6, I will cover them parallelly. So, is it okay for everyone?
Yes, ma'am.
Okay, ma'am, you take the session and after that we will discuss at the end of the day. Okay.
Yeah, okay. Okay, so it's 8:13. So I guess we can now start. Hmm. So, you have already seen the video lectures, right? All of you are already aware about the portion what are covered in week 7, right? Is there anyone who have not seen the video lectures yet?
I
Ma'am,
haven't
I
accepted.
all
I haven't watched. I haven't watched. Sorry.
Yes, ma'am. Me too. I too didn't watch it.
Not watch, ma'am.
ma'am, I
Mhm.
only watched the live sessions only.
I
It's
too
not
have not have
understandable.
just live
Okay,
session. Yeah.
okay. Okay, so I will cover all the main topics. If like I will suggest you to go through the lecture before the summary session. Okay, then it will be more helpful, because in that case you can discuss the topic with like which you are facing problem with, right? So that I can clear your doubts. Right. So from the next week, try to just watch the videos before the summary session. So for this session, I will cover almost all the topics. And whoever has already watched the video, you can ask if you have some specific doubt related to concept or maybe problem. Okay. So I will first write the content, whatever was in the syllabus. Uh, then if there is something else other than that, you can remind me. Okay, just I will first write the concept, I mean, yeah, contents. So maybe first we read about uh, polynomials, right? Functions with some example, and then maybe sequence, right? Sequence and subsequence, limit of a sequence, convergent, divergent sequence, all type of thing, and then limit of a function, right? These were the only concept covered in week 7, right? I think some of you
Yes,
have
ma'am.
already seen the lecture, so you can just guide me. Is there
Yeah,
anything other than this? These are the concepts,
no,
right?
ma'am.
Okay.
Yeah. Yeah, some trigonometry part is also there.
Trigonometry.
Yeah.
Yeah, I just consider it under functions. So it's functions mean trigonometric functions too. Okay, so these were the concept. So in early weeks, we already know what is a polynomial, right? Polynomials are basically in this form: ai x power I equals to 0 to n, where this is called the exponent and this is called the coefficient, right? So this is something which is familiar to all of you. So if we can name the polynomial in various way depending on the degree of the polynomial, right? So when the degree, I mean when n equals to 1, then we will get some polynomial like a naught plus a1x, right? So this is a polynomial of degree 1, and we can say it as a linear function, right? Or a linear polynomial or a straight line, anything, right? Similarly, polynomial of degree 2 is called quadratic function, right? This is called quadratic function. For cubic, it's called cubic function. So we can name it. In general, we will say it polynomial of degree n. Okay. So there is nothing new. I already know about the polynomials. I mean, maybe in your week 4, we covered it, right? What is a polynomial and how to plot the graph for any given polynomial, and how to calculate the equation of the polynomial from a given graph. So all of you are comfortable with this type of thing right now, right?
Yes, ma'am.
Okay. So then next concept is function. So can any one of you can unmute yourself and let me know the definition of function. What is a function? Suppose we have a relation f from a to b. So when can we say that f is a function? Any one of you can just unmute yourself and describe what is a function.
Ma'am, when the values of set A assign the values of set B.
So some terms are important, right? Values of a, I mean, it's
One
And
set
there
it's
to
is
the
meant to
value
be
of another set,
unique
ma'am.
unique
yes,
output for every input,
Or
yes,
we
right.
consider every image as a one pre-image or unique
and
pre-image.
every input should be mapped to some
Mhm.
output.
Yeah.
Yes, right. So
Mm.
this is important. Every input should be mapped. That means each element, okay? Each element of A, each element, this each word is really important. We have to map each element of A. That means each input to a unique output, okay? Map to a unique output, okay? So this the word each element and the word unique output, these two words are really important, right? So all of you are already aware about it. I mean, if we have a set A, set B, then for each element we have to map to a unique element of B. This is not possible. Like one element cannot map to two different elements, right? So this is not
Then
a
it is not a
function.
function.
Yes, right. This can be a relation, but this is not a function, right? Okay, Tushar, we just started week 7. This is the summary session for week 7. Till now, we covered just a polynomial, which you already know. And then we started with functions, okay? So if we have this type of thing, this is possible, right? I mean, this is possible, right? Two element can map to one element. In that case, the function is not one, but this is a function
Many
at
one.
least, right? Right? But not one, right? So these things are already very, like, all of you are very comfortable with this type of things, right? The definition of function, one function, onto function, right? And the vertical line test and horizontal line test. I mean, if it passes the horizontal line test, then we will say the function is one. And if it passes the vertical line test, then we will say that it is a function,
Yes, ma'am.
right? So all of you are comfortable with this type of thing, right? And if a function is one plus onto, then we say that this function is bijective, right? And a function is bijective means it is basically invertible. I mean, bijectiveness and invertible are basically same, just terms are different, but the meaning is same. Okay. It was just a basic definition of function, just to recall, because all of you already know what a function is. It was just for recall. So if we want example of function, so first, polynomial is a function. Okay, so polynomial of degree n is an
Ma'am, will
example
you
of
tell
function.
onto function? Like,
Okay, so onto function means, we know that if we have this, with this A is said to be domain, right? And this B is said to be codomain, right? And what is range? Range is just the image of F, right? Image of F, right? That means range is collection of all those element which has pre-image, right? So onto function means when the range is equals to codomain, then we will say the function is onto. That means this is your codomain, right? So this B is your codomain. This is a onto function, right? Because in B, suppose we have n element, and if we can find pre-image for all the element, then we can say the onto function. Okay, if there is one element for which there is no pre-image, then we cannot say it is a onto function. Okay, just if we want to check the Venn diagram, so in that case, this is a function, this is a function too, right? Both of them are function, but this is onto, but this second example is not a onto, because here this element is there, and for this element we don't have any pre-image. Okay, so this, in this example, the function f is not a onto. Okay, is it clear?
yes, ma'am. Thank you.
Yeah, so just one line, when the range is equals to codomain, then the function is onto. Okay, if the range is subset of codomain, that means a proper subset of codomain, then the function is not a onto function. This is a one line statement. Okay. Okay, so if we want example, first example is polynomial. So polynomials are example of function. Second, exponential function. So in your week 5, you covered the exponential function, right? Which is in this form, where a is not equals to 1, right? Because if it is 1 equals to a constant function. So this is the exponential function, and we know when a is greater than 0, the graph is like that, and when a is less than 0, the graph is like that, right? So this is the exponential function. Then you have logarithmic, right? Log a base x, right? So also last week you covered the logarithmic functions, right? And for logarithmic function, we can see this type of graph, maybe this type of graph, right? When a is greater than 1 and when a is greater than 0 and less than 1, right? These things are fine, right? Any doubt with exponential and logarithmic function? If you have, we can just discuss. Am I audible?
Hey, you are audible. Could you explain this once again? Sorry, I was out of track.
Yeah, I mean exponential function and logarithmic function. These are just two example for functions. Okay, so the graph of exponential function is typically look like this and this. Okay, and the logarithmic function is this or this. Okay, dependent on the values of
I think your voice to this thing is not synchronizing, because when you are actually saying this, I was not able to see where your cursor, where you're moving the cursor.
okay, so this is maybe because of network. So I'm
Yeah,
just
even your voice is
to
your voice is also
graph
breaking actually.
Yes, ma'am.
uh, is-
Now we are not able to hear you. No, we couldn't hear you. At least I couldn't hear you.
am I audible now?
Yes,
Yes,
ma'am.
you are audible.
Okay. Just sorry for the inconvenience. Just wait for 2 minutes. I
No hassle.
Hello? Hello?
Yes, yeah, we can
Yeah.
hear you.
Am I audible now? Is the voice clear?
Yes,
Yes,
clear, crystal clear.
Okay, okay. So, yeah, we were talking about the exponential and logarithmic function, right? So, we know about the domain, codomain of these two functions.
Sorry, Samita,
Also,
your screen is not visible.
yeah, just I need some time. I need the access co-host. So, let me give it, then I will. Okay.
Yeah, fine.
So, yeah. Uh, so, do you have any doubt with the exponential and logarithmic function?
Yeah, as I told you, I was actually I wanted to ask you about the graph that you drew, and uh, I had some doubts there when you were actually.
Yeah, I just drawn the graph of exponential and logarithmic function. So you already know how the graph is, right? So it's like nothing new. So when a is something greater than 1, we know the exponential function is increasing function, right? And similarly for the logarithmic function too, right?
Okay.
And when a is less than 1, then for exponential function and logarithmic function both, the graph is a decreasing graph, right? That is what I just drawn that time. So if you don't have anything to ask, right, like basic thing, then we will again cover this type of thing later. But we can then start with trigonometric functions, right? So
Sharing your screen.
yeah. I have still not shared my screen. Uh, just wait. Yeah. Okay, okay. Okay, so I just need some time to share my screen. Um, okay, so mm, until then we can like just talk to about what a trigonometric function is. So you all know about sine function, cosine function, and tangent function, right? So we have a total 6 trigonometric function: your sine function, cosine function, tangent function, secant function, cosecant function, and cot function, right? So you also have the formulas using this 6. So there are basic relation between sine and cosec function. Sine function is 1 by cosec, and cos function is 1 by sec. Tan function is 1 by cot. All of you are already aware about this thing, right? This
yes,
was
ma'am.
in your
Yes, ma'am.
yeah. It was just the 11 syllabus, right?
Madam, are you sharing your screen? Or?
No. I just need some time. I still I'm not a co-host from the iPad, so just let them make me co-host, then I will share it. Okay. So I have seen some of you were asking about the okay. Can you see my screen now?
Yes.
Yeah,
Yes,
now
ma'am.
it is.
Okay. So some of you were asking about the trigonometric functions. So do you have any doubt or specific issue with the trigonometric function? Then I will focus on this type of thing. That is what I am asking.
At least I would appreciate if you can do it. I don't know about the rest. You can also. If it's only for me, then it will be much.
Can you repeat? I cannot hear
No,
you.
no. For me, it will be useful if you can describe it. But if for others, if they are all convinced, maybe then you can move on with the
No,
topic.
no, I will describe fully, but if you have some specific doubt, then I will focus on this particularly. So I will describe it fully. Don't worry about it. Okay, so we have 6 triangles, right? Sin x, cos x, tan x, that means tangent of x. So then cosec x, sec x, and cot x, right? So am I audible?
Yeah, you are.
Yes, ma'am.
I
Yes,
can.
ma'am.
Yeah, we can hear you.
Okay, okay. So yeah, these are the basic trigonometric functions, right? So all these functions has their own power series expansion. That means we can write it as a infinite polynomial system, right? So all these trigonometric functions are basically infinite polynomial, but from your point of view, it's not needed right now. So I'm not describing this, but for now we will take it as a separate function. That means your sine function. What is your sine function? We know the graph of the sine function is like that, right? Right? This is the graph of the sine function, right? And we have a your class 10 standard or 11 standard for this type of values, pi by 3, pi by 4, pi by 6, and by 2. So we know the values, so we can consider the sine function, and we know at 0 the value of sine function is 0. That is why it is going to the point 0. At pi it is again 0. At any pi it is the sine function gives a value as 0, right? So it will basically cut the x-axis at every pi, every n pi, for any n belongs to the integer. Okay, this is basically 0, pi, 2 pi, minus pi, minus 2 pi, and so on. Okay, so this is the sine function, and this is the graph of the sine function. Okay, so that there are 3 main trigonometry function, which are sin x, cos x, and tan x, and using this you can find cosec x, sec x, and cot x, right? So as you know, sec x is cosec is equals to 1 by sin x, right? And sec is equals to 1 by cos. And cot is equals to 1 by tan, right? So clearly you can understand only sin, cos, and tan, these 3 are your main function, and another 3 function you can just consider as a just 1 over this function. So these 3 are your main function. So this is the graph of sin x. Similarly, cos x, this is the graph of cos x. Okay, maybe these the graphs are not perfect because I cannot draw it that perfectly. So you know that when the theta is 1, right? Because similarly when pi when pi, then cos theta is -1. So we can take the values, then we draw the graph. Okay. So this is the graph of cos x. Okay. And similarly, we can draw for tan x. Okay. So this is the, sorry, not like that. This is,
So I had a
okay.
question for the sin x and cos x, this sinusoidal graph will always be the case, is it?
Hmm. Can you repeat?
For sin x and cos x, the sinusoidal graph that you are drawn, I do understand that they don't intersect at 0 and they have different the thing. So the sinusoidal movement is always the case. It will behave like that only.
Yeah. Sin x is always like that. I mean, we know that sin x and cos x are a 2 pi periodic function, right? So it will basically repeat after the 2 pi range. You can take 0 to 2 pi, a standard interval, then it will be just same type of, it will follow the same type of pattern after this. So it will be always same.
The oscillatory movement, like kind of
Yes,
oscillation.
yes. Yeah, kind of oscillatory. So this is just like wave, right?
Yeah, that's what. Okay.
Ma'am, is there any topics or questions asked regarding this, ma'am? These graphs?
Maybe not. I mean, just using the trigonometry function will not have any question. But you should know the graph, because you can have another questions like differentiability or tangent. In your last, in some, I cannot remember, but maybe were some question. So the graph of a sine x was given, and we had an interval, some -5 to 5. Then we had to conclude whether there are some point at which the I mean slope is 0 or not. You can say this point is such a point such that the slope is 0, right? I mean, if you draw the slope, it will be parallel to x-axis. That means the slope is 0, y equals to 0. Okay, so this type of question, I mean, you can have some question involving this graph, but not something direct.
Also, domain
Okay.
might be also asked, right? Domain or range also.
Domain,
Those
yeah, domain and range are always straight. Na? I mean, your x-axis is your domain. For all the graphs,
if
your x-axis is your
sometimes
domain.
range questions also might come, right? Or no?
Yeah. No. Yeah, it can come. So you can say that this is 1, right? You know, at pi by 2, the sin x takes the value 1. So this is 1. And all the peaks are same. Like all the peaks are 1.
The graph is
Like the
symmetric,
highest
right?
point is 1, right? Yeah.
1 to
And the
-1.
lowest point is -1, right?
Yeah.
So the range will be usually from 1 to -1. Okay. So,
Okay.
and the domain is the x-axis. That means the whole
Entire
real line.
x-axis.
Okay. Yeah, entire x-axis
Ma'am,
means
that
whole
means the
real line.
range. That means the range lies between. That means it is on y-axis, right? We have to
Yeah,
consider.
your codomain is y-axis and your domain is x-axis. Okay, and the range is just consider that much part where in which part you are drawing the graph. Okay.
Okay, ma'am.
Yeah. So for range, we have to consider just that part, for that part which we are using to draw the graph. Okay. So here the range is -1 to 1 and the domain is the x-axis. Okay. Similarly, for the cos function, the domain is the whole x-axis and the range is -1 to 1 again. Okay.
Is it open or closed brackets, ma'am? Range.
Yeah, this is closed bracket, because minus for at pi by 2, sin x attend the point -1, right? And sorry, plus 1, and at minus pi by 2 it attains the point minus 1, right? So if it is if this the point 1 and minus 1 they belongs to the range, that means we will take closed interval. Okay.
Okay, ma'am. Thank you.
Yeah. So yeah, any other doubt with sine and cos function?
Ma'am, hello.
Yeah, I'm listening. Yeah.
So, ma'am, in this sine and cosine functions that we have, these are the sine x and cos x are just the ratio of a triangle, है ना? So that the after which we get this type of curve and parabolic things. These are the ratio of sides of a triangle, na? Unit circle that we can say for visualization.
Yeah. Yeah, you can like from a right angle triangle, we can compute it, and yeah, this is true. And the graph is basically don't confuse this thing, this origin type of thing with graph. So that graph is just the movement of the point x comma fx. Okay, so we are just plotting the movement of this type of points.
Hmm.
And the right angle triangle thing which you are saying, this is the origin of this type of trigonometric function.
Okay. But this
So
tan graph of this tan function behaves little bit of different. I think that the because of it's a ratio of sine and cos x. So for some point of points in the number line, the cos is not defined. So that for that particular point, the graph goes this. I mean,
goes to infinity and minus infinity.
so I'm not sure about these things about this tan function graph.
Okay, so basically see, the for sine function and cos function, the range is bounded, right? I mean, the maximum point is 1 and the minimum point is minus 1, right? But what is tan function? If we talk about the formula, then tan x basically equals to sin x by cos x, right?
Yes, ma'am.
But there are some point at which cos x is 0. Then we will get some finite numbers by 0, right?
Yes, yes.
Some finite number by 0.
Ma'am, your voice is breaking. Ma'am, your voice
Yes.
is not clear.
Um, okay. So can you hear it now?
Yeah.
This is because of the internet issue. Actually, I'm facing really internet issue. But from the next class, it will not be the case. Uh, okay. So is it clear now? I mean, you can hear me?
Yes, ma'am.
Yes, ma'am.
Clearly.
Yes, ma'am.
No, sometimes it's really clear, and many times it's actually it gets interrupted. Almost it's
Yeah. The network is fluctuating actually. So from the next class, it will not be the case. Uh, so I just got this. Yeah. Huh. So
The
can
range of tan x is minus infinity to infinity, ma'am.
yes. The range of tan x is minus infinity to infinity. That is why the tangent graph is sometime it's tending to infinity at those point at which the cos x is 0. Am I clear? I mean, when the cos x is 0, the that graph of tan x will be tending to infinity depending on the value of sin x. Because if the value of sin x is positive, then it will be tending to infinity. And if the value of sin x is negative, then it will be tending to minus infinity. Okay? Because then we will depending on the value of sin x, we will get plus, suppose plus 1 by 0 or minus 1 by 0. Okay, so when we will get plus 1 by 0, then tan x will be tending to infinity, and when the value is minus 1 by 0, then the value of tan x is tending to minus infinity. That is why the range of tan x is range of tan is minus infinity to plus infinity. Okay.
Ma'am, what is domain of tan x, ma'am?
Domain of tan x is the whole real number.
Okay, whole real number we can't say na. We have to exclude those points in which the function is not defined.
Whole
No, no,
y-axis
no.
or whole
Yeah,
Ma'am, for
x-axis?
sin x and
actually,
cos x also domain equals to real numbers, right? ma'am?
yes, yes. So, yeah, here we have two type of sense. I mean, you can say the whole real number is domain. You cannot say, because there are two type of mentality in this case. If you consider, actually, there is a term called extended real line system. Okay. So, what is the extended real line system? In this extended real line system, we consider the infinity and minus infinity as a point of our real line. That means we are just including the points infinity and minus infinity as a ending point of the real line. Okay, this is called extended real line system. Okay, so if you go through the extended real line system, in that case, we will say that domain is real number. Okay, so in that case, we don't have any problem because we are considering infinity and minus infinity as 2 points of real line, the ending points of real number, boundary points of real number.
Those are
But
not included.
now those are included. If we are talking about extended real line system, that means we are extending the real line. Okay, in that case, we are taking infinity and minus infinity as a point of our real line system. So in that case, we will say the domain is R, because here infinity and minus infinity are 2 points. But there are second thought, in this type of thought, we cannot consider infinity and minus infinity as a point of real number, which is normal to you. So in that case, we will exclude the point at which cos x is equals to 0. Okay. Am I clear with the thing?
Yes, ma'am. Yes, ma'am.
Did you get my point,
Yes.
or I should repeat it?
Got it.
Oh.
Madam,
So the graph of tangent, yeah, yes.
okay, madam, the curve, the sine and the cost, so both are oscillating negative and positive. What is the difference, madam? I'm not able to catch the
Look at
difference.
0. Yeah, look at 0. At 0, sine x is passes through the origin. But cos x, look at cos x. At 0,
Okay.
the value of cos x is 1. Okay.
Okay, based
If
on
you
that,
draw
what we studied the earlier 30, 45 degree, 60, 90. So based on that, the values are oscillating. That only.
yes, yes,
Okay,
yes, correct, correct. So let me draw the graph together so that you can just notice the difference. So this is the graph of your sin x, right? It is passing the origin. That means at 0, it is giving the value, but the graph of sin x is like that.
is correct. Then 1/2, right? Yeah.
Yeah, just we are shifting the I guess my screen is lagging, right? So we are just shifting it with pi by 2 points. Okay.
Okay. Okay. Okay. Understood, ma'am. Thank you.
Screen is not visible, ma'am. Your screen.
Yeah, yeah. Wait. I'm really facing a serious network issue. So I'm really sorry for this inconvenience.
Ma'am, it's an Wi-Fi driven or it's mobile based?
No, no, no. It's mobile based for today. That is why I'm facing issues.
And we can
From next day, it will not be the case.
try once aeroplane mode and then turn it on again, on and off for once.
Yeah, I just tried it. But actually, I'm facing a network issue. That's right. And now you can see the screen, right?
Is it a bad weather there? I mean, that should be one of the.
No. The network is going slow itself from some day, but
Yeah, we can
yeah.
continue. No hassle.
So yeah. So is it visible now?
Yes,
Yes.
ma'am.
Yeah. So the yellow curve is graph of cos and the blue curve is graph of sin x, right? So this is the definite difference. We are shifting the graph of this is not perfect, not perfect, but you can I think get what is the difference between the cos x and sin x, right? Is it fine?
Yes, ma'am.
Okay. And okay.
And
So
even though
let us move
the
with tan x.
sorry, even though the cos and sine are different, they don't actually superimpose. They are a different thing. I just want to know are the intervals are regular intervals, equal intervals between the two?
Yeah. Yes. Yeah. Both are
Thank you.
periodic function, so it is same. Intervals are also regular.
Okay. Thank you.
Okay. So let me put the graph of tan x. So you can see the graph, right? So this is the graph of tan
You
x.
can
You can
also
see
open
this is
them
also
on Desmos now.
yeah, because of network, so it will cause more hurdle maybe. So on Android, it something like that. I mean, you can also check it in your Desmos by your own. Okay, so the graph of tangent is also a periodic function, and it's again a periodic function of period 2 pi, and it's look like that because we know the range is minus infinity to plus infinity here, so it will be something disconnected. Okay. Um, so up to now, is it fine? I mean, with trigonometric function, or if you
Ma'am,
have
what
any
do you know about period, ma'am?
question?
Periodic function, periodicity.
So periodic function means basically repeat. I mean, the graph will be exactly same after some time. So you can say we have, I just drawn 4 wings here. We have infinite time of wings. Okay, so when we can extend the x-axis and we will get infinite time of wings like that. So you can say like each wing are basically same. Okay, so they are basically same image of just copy paste of each other. Okay, this is what will have the same after this certain term.
Ma'am, how can we
So
declare it is of a period of 2 pi or in a range?
so basically the point, this is minus pi by 2 and this is pi by 2. Okay, when x equals to minus pi by 2, tan x went to minus infinity, and when x equals to pi 2, tan x goes to infinity. Okay, so minus infinity to minus pi by 2, we will get one wing. Similarly, pi by 2 to 3 pi by 2, we will get another wing, and it will continue. Okay, so the range is, I mean, this portion is, the length of this portion is 2 pi, right? That is why I'm saying it is a periodic function of period 2 pi. Okay, so if we write it mathematically, if okay, if fx equals to fx plus pi for all x belongs to the domain, in that case, the function is periodic function. If there were some n, okay, if it were n, then we will say this is a periodic function of period n. Okay. Is the definition clear?
Yes, ma'am. Okay, ma'am. Thank you.
Okay. Okay. So yeah. So these were main thing in your trigonometry function. Other than this, these were just concept related thing. So you will get so many formulas you have already seen in your 11. You have to remember all these formulas, at least the important formulas, to solve some problem. Okay.
Ma'am,
So
but
if
the
you have
distance
any doubt
between
regarding,
yeah, but the distance between minus pi by 2 to pi by 2 is only pi, right, ma'am?
yeah. Okay, sorry, huh? Yes, pi. So tan x is pi period function. Yeah.
Okay, ma'am. Thank you.
So what is the distance you can consider? But and so sin x and cos x are 2 pi periodic function. Okay. Similarly, from the graph you can observe this type of thing. Is it fine?
Yes, ma'am.
Okay, so it's clear for all of you. Then we can move to the sequence. Otherwise, if you have doubt, we can.
There were several questions about this trigonometric functions, and those were really challenging.
Mm, see, if you want me to solve question, I mean, you will not have any direct question using this, but right now I cannot think any that type of question from trigonometric function. Better, there are some question in your activity questions and your practice assignments, so you can try to solve them. Then I will, or some of the instructor will cover the open session. Then we will take it. Okay. Because
Okay,
right now I cannot remember like some problem with trigonometric functions.
okay, ma'am.
Yeah. So for trigonometric function, the only key is try to remember all the formulas, right? For example, some important formula I can just say sine 2x. Okay. So what is sine 2x? This is 2 sine x cos x. Okay. Cos 2x is
Cos square x
cos
minus
square
sin
x.
square x.
Yes, right. Very good. Okay. So these are two important formula. Other than that, 1 plus cos 2x is what? 2 cos squared x. 1 minus cos 2x is
2
2
sin square
sin
x.
squared x. Right. So these are 3 to 4 formulas. You should keep them in mind. I think it's like if you have this type of formula in your mind, then you can just apply the formulas and you can solve. Trigonometric problems are not difficult, right?
Can we have their derivations? I mean, how these
I
formulas
mean,
came, like.
sure, sure. So just for this, let us consider this. Okay, so we will prove this formula using this two. Okay, so we have 1 plus cos 2x. Okay, and we know cos 2x means cos square x minus sin square x. Again, we also know that 1 means sin square x plus cos square x, right? So we can write it as sin square x plus cos square x minus, sorry, plus cos square x minus sin square x. Just putting the value of 1 and cos 2x. Then sin square x will be cancelled out. So we will get 2 cos square x. Easy?
What did
Easy,
just
right?
happen? Yep.
Yes.
Yep. I didn't got.
You didn't got? You didn't get it?
Yes, ma'am. I didn't get it.
Okay. So what is the problem? I mean, at which step you was not clear? I put the value of 1. We know that sine square x plus cos square x equals to 1. Okay. So I put sine square x plus cos square x instead of 1. Okay.
Hmm.
Then I put the value of cos 2x, which is cos square x minus sine square x.
Okay. 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 Yes. Yes,
Clear
ma'am.
now?
Yes, ma'am. Yes, ma'am.
Now? Okay. So similarly, can we prove the second, I mean the 1 minus cos 2x? So we will get minus here and plus here, right? Right?
Hmm. Yes, ma'am.
So cos will be cancelled out and we will get 2 sine square x in the result, right?
Yes, ma'am.
So these are interesting and these are not difficult. If you are interested, you can just have 2, 3 basic formulas and just apply them, and you can uh, like find all the trigonometric formulas. These are really interesting. And what I can remember, you know, the activity question, you have some this type of question. Okay, and also I solved this type of question. You can check it in the YouTube. But also I would suggest you that at least first try on your own, like try to solve them first. Then if it is not going well, then you can check the videos. Okay.
Okay, ma'am.
Yeah. So these are some easy steps. You can just apply the formula, then you can do this. So these are 3, 4 formulas. You should sine square x plus cos square x equals to 1 and cos 2x and sine 2x. This 2, 3 formula just try to remember. Another
Ma'am, is it
else you
last
can
year, ma'am?
solve.
The videos you have explained in YouTube?
No. It is not last year's video. This is a fresh, just recorded for the solution. I just shared the playlist in the last class, na? So you can find them.
Okay.
If you're not in the last class, just go to the official channel. Then just go to playlist, assignment solution questions. Then you can find. Okay. Okay. So any other doubt with trigonometric functions?
Uh, Kind of little different, but I just wanted to know about this application of this trigonometric function in the data science. Where will be applying it?
Okay. So I'm not very sure about it, about the application. So I mean, in data science, I'm not very sure. But here you need some, like, you have to play with functions. That is what, like, at least here we are using it because you need to play with functions and you should be more comfortable with them. That is why we need this functions here. And for your data science point of view, I'm not really sure. I mean, yeah.
Okay. Okay, ma'am.
Okay. So if it is okay, then we can move to sequence. Okay. Okay. So what a sequence is? Any one of you? What is the definition of a sequence? If I just ask you single line, so what will be the definition according to you?
Defined order of set, maybe.
It
Okay.
is a
So any other
continuous elements.
continuous elements? Okay. Okay. Any other explanation and any other definition? Yeah, you no worries. I mean, you can try at least.
Basically,
It
pattern
is a
that follows.
pattern.
A basic pattern that,
I mean, it's a pattern, a kind of pattern that the event
yeah.
has a pattern or a that follows whatever the event.
Okay. So, okay. So, let us just focus on the word definition. I mean,
Ma'am, it is a collection of objects in which repetition are allowed or orders matter.
yes, right. So we can express this your line. I mean, it is a collection of object in which repetitions are allowed and order matters. So we can say this thing in another language, which is like sequence is a particular type of function for which the domain is natural number. Can you just connect your line with my line? Just think the definition of function. What did you say? Just repeat your line.
Me?
Yeah. Just repeat your line.
Ordered set of objects.
Where repetition is allowed, right?
Okay, there was another guy who said this.
Yeah.
Yes.
I want him. I mean, I cannot see the name actually. That
It
is
is
why.
a collection of objects in which repetitions are allowed and order matters.
Yes. So if you say this, I mean, it is a collection of object where repetition is allowed and order matters. And I am saying that it is a particular type of function where the domain is natural number. So can you connect this to line? I'm saying to everyone, everybody. Can you connect this to line?
No, ma'am, we didn't get them.
Okay, if the domain is entire natural line, then how will the repetition will occur?
Okay. Let me write the two statements. Okay. Then I will describe how they are connected. Okay.
Okay.
This is the first statement, and the second statement is okay. So if let's start with the example. Okay. Suppose we have 1, 2, 3, 4. So like okay. So this is a example of a sequence, right?
Madam, in a set, the repetition not allowed, right?
Okay. So repetition is allowed in sequence. I mean, you can take one element several times
I
in
understand
sequence.
the definition of sequence, what you written. What I asking, we learned earlier the set, the collection of it, and the repetition is not allowed, right?
No, repetition is allowed
I'm talking
in
about
sequence.
earlier what we studied in the set theory.
Okay. Yeah. Okay. So there are, I mean, set. Okay. So in according to your set theory, yeah, repetition is not allowed. This is true. But that type of set where allowed and this matters. If you are taking two twos, then two twos are considered as two different elements. Okay. I cannot remember the exact term. Um, Maybe ordered set.
Their
No.
their indexes are different.
Yeah. Like just based on the ordered, I mean, maybe ordered set or what, I cannot remember the exact term. So just
Ma'am,
for now,
ordered
let
pair.
us, no, not pair. It's just a set where indexes also matters. I mean, the first two is image of the element 2, but the second two is image of the element 3. Okay, that is why we will consider this different two as different two elements. Is it clear? I mean, there is
Excuse me. So
more
what you
to.
trying to say? The elements may be same, but it is a position is different, correct?
Yeah, right. Because the order matters here. Okay, so
Understood. Understood.
yeah.
Okay, numbers are in another dimension then.
Not dimension. So this is not exactly set. This is maybe ordered set or what, I cannot remember the exact term, but this is kind of set where the order matters. Okay. So just for now, let us not use the word set. Just use the collection of number. Okay. Collection of number. Okay.
Okay.
Yeah. Okay. So this is the equation. This is the example of a sequence, right? So if I say this is a function which maps 1 to 1, 2 to 2, 3 to 2, to 2, and so on, is it fine? This is a map which is mapping the number to some set of real number. Dependent in the first description, in the first line, we said that the collection. Am I audible?
Your voice is breaking.
Oh, but can you get my point? I mean,
Yeah,
or
we
you are
understand.
facing
We understand. We
difficulty?
understand.
You continue, sir. Somewhere it's breaking. That's okay.
Yeah, then you can stop me and just ask me again. Okay, then I will repeat them if you are not getting
Okay.
this point
Yeah,
because
if
of
it
the
is
break.
continuously breaking, na, so we will allow.
Yeah. Yes. Okay, so the first statement is collection of number where repetition is allowed and order matters. Okay, so just take repetition is allowed. Here we are taking repetition. Okay, that means the image of 2 is 2, 2 is going to 2, 3 is also going to 2. This is allowed in function 2, right? If this is the domain 1, 2, and so on,
Many to
this is
one.
real number. Yeah, this is basically many to one function, right? So repetition is allowed means a many to one function, and order matters. Order matters means one element can go to one element, one unique element. So for one element, it is not possible to go to two different elements. So we can take this as in one place, we can write only one number, right? So the number which is in the first position, we can take it as the image of the first number, I mean image of 1. The number which is in the second position, we can take it as the image of the second number, and so on. Is my point clear? I mean,
Yeah, understand.
Okay, every element is unique.
Basically, it defines a function.
yes, it is not like that. I mean, it defines a function. This is not a right term. It is a function. It is a particular
Yeah.
type of function. For
Yeah.
function, we can take any arbitrary domain, which is a subset of real number. Natural number is also a subset of real number, right? So
Uh,
this is a function where the domain is particularly the natural number.
okay.
Okay.
Understood.
So is it clear to all of you? If I ask you for in any situation that what is the definition of a sequence, just in one line, then you have to say the definition of sequence. Sequence is basically a function where the domain is a natural number. Okay. Can you repeat?
Till infinity, right?
Yeah, 1 to infinity. I mean, here 0 to infinity, because natural number, here natural number starts from 0. So 0 to infinity. Okay.
For this course, we are saying that natural numbers are
Yeah,
from
yeah.
zero, right?
Yes, yes. Because we are
Okay.
following the Python's logic. So here natural number starts from 0. So the
Yes, ma'am.
zero place, yeah. So 0th place to infinity. We can we have to place some number at each place, right? So basically, sequence is a function where the domain is natural number. Clear?
Okay.
Any doubt?
No, ma'am.
Okay.
So in this case, it will be like f of 0 is 1, f of 1 is 2. So it goes like that, right?
Yes, 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 yes. Correct, correct. So in general, we can define a sequence like that, right? AN or FN. Basically, this is the image set. The sequence is the image set for the function f. An equals to f of n. We are collecting the range of the function and we are denoting it with sequence. Okay.
Okay, this was range.
Interesting, no?
Now this connects to the previous topics that we have studied.
Yeah. Yes. So first we learned what a function is, then we are learning what a sequence is, and the sequence is basically a particular case of the function.
Here codomain is range, right?
No, it depends. I mean, because the function is something in underline. So if you take the codomain as R, the whole real line, then the codomain is not range. But also you can take the range as your codomain. Function is the underlying thing now, because we are not directly explaining it as function. We are just taking the range set and we are saying that it is a sequence. Okay. But there is an underlying function behind every sequence. Okay. Clear?
Yes.
So everyone fine with this thing? Interesting?
Yes, ma'am. Yes, ma'am.
Okay. So now we have sequence and we know that sequence is nothing but a function. So we can talk about limit. This can be convergent, this can be divergent. So limit, if suppose this is the natural number, okay? When we are talking about sequence, we will take the domain always as a natural number, okay? And the codomains as R. Suppose this is a sequence, okay? The graph of the sequence. So we know graph of function exists. I mean, if we have a function, then we can draw the graph. And right now we know that sequence is a particular type of function. So obviously for sequence also we can draw graph, right? Suppose this is the graph of the sequence. Then we can say when n, the natural number is tending to infinity, this graph is tending to 0, right?
Yes, ma'am.
And if we have the graph like that, then as n tending to infinity, this graph is also tending to infinity, right?
Infinity.
So we have both the cases. I mean, when n tending to infinity, we can have the graph tending to some finite point, or it can be tend to some infinite point. That means infinity or minus infinity. Okay. So whenever it will tend to infinity, we will say the function, that means the sequence, has a divergent sequence. And when it will tend to some finite point, then we will say the sequence is a convergent sequence. Clear?
Is it in the convergence sequence?
So there are so many examples. So for convergent sequence means okay. So if we say this is a convergent sequence, then we will always mean that when n tending to infinity, the sequence, that means the nth term of the sequence, will be tending to some finite point. So this is the convergent sequence. For example, suppose 1 by n. Okay. So here the function is 1 by n. Okay.
This one.
So we will have 1, 1, 2, 1 by 3, and so on, right? So when n tending to infinity, we know this will tending to 0, right? So this is an example of a convergent sequence. Similarly, suppose 1 plus 1 by 2 power n. Okay. So this will tending to 1 as n tending to infinity, right? Okay.
Yes, ma'am.
Yeah. And divergent sequence. Suppose our function f of n is n. Then it is divergent, right? As n tending to infinity, f of n will be tending to infinity, right?
Yes, ma'am.
Okay. Then we can take this as minus 1 power n. This is a special case. Okay. So this type of case is also divergent. There is a different name for this type of case. Sometimes we may call this type of case, I mean, there are two point of view. Okay. The first point of view says this is a divergent sequence, which is the case here. I mean, here we will consider it as divergent sequence, but there is a different point of view in which some mathematician take this type of sequence as a oscillatory sequence. Okay, because you can see that it basically oscillates between the 1 and minus 1. So it will take the values 1, minus 1, 1, minus 1, right?
Ma'am, this will violate our rules for exponents.
What?
The base, the coefficient should not be negative now. I mean, in the exponents term, I think. Oh, yeah, yeah. Sorry.
No. You're correct. But the coefficient is not negative, because when we are talking about exponential function, then we were taking the x, I mean, a power x belongs to real number, right? So if x belongs to real number, it can be half, 1 by 2. So minus 1 power 1 by 2, then the result will be complex, correct? But here we are taking the domain as natural number, so we cannot take this fraction type of thing. So here we don't have any disturbance. Okay.
Okay. For the for the power of 2, it will behave like quadratic, and for the 3, it will just flip around. Yep.
Yeah. So basically here the movement is like it's going to 1, is going to minus 1, 1, minus 1, 1, minus 1, something like that. Okay. This is basically a oscillating type of thing. Okay.
Yes, ma'am.
So some mathematician says this type of sequence as an oscillatory sequence. But here we consider all divergent sequence. Okay. So here we will consider the definition of divergent sequence means the sequence which are not convergent. Okay. So oscillatory sequence are not convergent. So we will take it as divergent sequence. Okay. So this is one example for divergent sequence. Is it fine so far? So far up to now?
Yes, ma'am.
So we can solve some problem. Suppose we have some.
That is
The
not the
function.
graph of minus 1 power n.
No. This is not the graph. I am just saying this. It is oscillating like that. I mean, 1 minus 1 or 1 minus. We will take the point. Okay.
Yes.
Yeah.
Also, this graph
Then
doesn't exist also.
um yeah, actually we cannot draw it. I mean, it's fluctuating, so we cannot draw this like that. But you can
Yes.
imagine them, right? At each natural number. In real line system, if we take the codomain as real line, then we can draw it. I mean, each natural number. But if we take the domain as natural number, I mean, while drawing, then we cannot draw the graph. It is not continuous. I mean, this is
Also,
some
it is not a
points.
function only, so we can't draw.
What? This is a function. Why? This is a function. We can draw. I mean, if
Okay.
you take the domain as like not domain, the domain is natural number, but suppose our x-axis is real number, okay? Then we have 1, 2, 3, 4, and so on, right? So
Okay.
at 1, the value will be -1, right? That means this point. At 2, the value will be 2, this, this, this. Okay. This is
Okay.
the graph here. I mean, the graph
This is the
is
point.
not
This is not a
continuous.
graph. Yeah.
No, see, what is the graph? Graph is just collection of all those points.
But it is not continuous.
I mean, yes, this is not continuous, but this is a graph. Still, this is a graph.
Okay. Then
Graph of a
just
function
one
is
thing.
just collection of all, yeah, all the points. If you collect all the points, you will get the graph.
Okay.
But this is continuous graph. Okay.
Yes.
Is it clear? I mean, this
Yes,
is a
got it.
function. If we are talking, yeah. So you were talking about sequence. That means always this is a function. If it is a function, we can draw the graph, but this may not be continuous.
Yes, got it.
Yeah. Okay. So suppose we have an example, some 5n cube plus 2n by okay. So this is suppose a sequence and we have to find the limit. What is the limit? Anyone of you?
In the denominator, we have natural log of 2.
No, this is 1. Sorry, I should not write it. 3n square plus n square.
See, earlier in functions, we always used x, but in sequence, we are
We
primarily
will
using
use n.
n.
Yeah.
And
Yeah.
that x and this n are totally different, right?
Yeah, actually, these are just suitable notation, nothing more than that. I mean, because we are taking natural numbers here, that is why we are denoting with it with small n. Okay, because
Okay,
small n is more suitable to denote some natural number, right?
okay, okay.
Yeah, you can take x, no problem,
Oh,
but it is not something suitable, na? If you
okay,
take n, then it's good, like it's well fit.
all right. Okay, thank you.
And how can we
Then,
find if a function is given, what is the limit? Is it a suitable range or
No, see, when you are concluding the limit, just simply I will say that don't complicate it. Just simply do simple steps. That means suppose we have this function, okay, and we have to calculate the limit, okay. So we have that. If we put in infinity instead of n, we will get infinity by infinity, right? So this is nothing. I mean, this is nothing finite. So
here we have to use El Hospital rule, right? Like
yeah,
derivative.
but there may be some another way too. I mean, you can use the L hospital rule, no doubt. But if you can take some factor as common, then you can cut them out, cancel them out. Then it may be the case. I mean, if you have this type of sequence, you can take n cube common and just cancel them out. Okay. So I will divide both the term with n cube. Then we will get 5 plus 2 by n square by 3 plus 1 by n. Right? So because we have n tending to infinity, 1 over n is suitable for us because it will give the value 0. So this is something finite, we know. So we will always try to express the given equation in this form such that we can get something finite. Okay. If you now put infinity instead of n, then we will get 5 plus 0 by 3 plus 0, right? So this will be equals to 5 by 3. Is it fine?
Yes, ma'am.
Okay.
Yeah. Any doubt?
Now we'll
Just
be doing
explain
that.
once.
One by one, please. I cannot hear.
Explain once again. The n cube,
Okay.
how did you taken out from n cube?
I mean, if you take n cube common from this term, 5 n cube plus 2n, if you take n cube common, then what will be the portion? This will be 5 plus 2 by n square, right?
Yes.
And similarly, we can take common n cube. So n cube, this will be 3 plus 1 by n, right?
So we are cancelling n cube so that we are
Yeah.
concluding as 5 by 3.
Yes. Because n is tending to infinity, na? So we will always try to express the equation such that we can get something 1 over n type of thing. So that this term will be tending to 0. Okay.
Okay.
Is it clear to all of you?
Now, what are the basic rules for the infinity type of infinity involving calculations?
If you have sequence, if you can take some factor as common, then always try to do this type of thing. If there is nothing to take common, then use L-Hospital rule. Okay. These two are key factors.
Air
Yes.
hospital.
L-Hospital rule. You will learn about L-Hospital rule in your next week 8. But for now, I guess you don't need L-Hospital rule. So you can take some factor common always for a sequence, like at least which example you have. Okay. So example 2, suppose limit n tending to infinity minus 32 n square plus 2 by 3n cubed plus 2n squared plus n plus 1. Okay, this is another example. Try to solve it in similar manner and let me know the answer. Just try to solve it similarly as the earlier one. Then let me know the answer.
Is it minus 16?
Okay, minus 16. Let us wait for others. Let everyone give the answer, then I will.
0.
I did not calculate, I did not substitute the numbers, but from what I look, it appears it should be 1 by 3
1
or,
by 3.
or minus 1 by 3.
Okay, plus minus 1 by 3. Okay. Any other?
Ma'am, what if is there only one n? So if we substitute infinity, 3 into infinity, what it will become, ma'am? Infinity. So
Infinity.
infinity plus anything becomes?
Infinity. No matters what you are adding with infinity, it will always be infinity. Infinity into infinity is infinity. Infinity plus infinity is infinity. Infinity
Infinity plus anything.
is infinity.
Here we are getting the same in denominator, ma'am.
Okay.
Zero.
So this is
Then it should be 0. Yeah.
yeah.
In the
Okay.
denominator, everything is infinity. Infinity cube infinity, infinity into 3 infinity plus infinity. So infinity.
Yeah. Okay. So the first observation is if what is the power in this portion?
2 is common.
And what is the power of this portion? This is 3, right?
3.
Okay. So this is the first observation. If you have this type of thing, I mean, power in the above portion is less than the below portion, then first conclusion is limit is 0. This is just after seeing the sequence you can conclude. Okay. But how to solve? Again, similar type of things. I mean, you can take n cube as common. We will take common the highest degree from here. Okay. So we will take n cube common. Then we will get minus 32 by n plus 2 by n cube. Right? And from here we will get n cube 3 plus 2 by n plus 1 by n squared plus 1 by n cube, right? N cube will be cancelled out. And if you put infinity, then we will get 0 plus 0 by 3 plus 0 plus 0 plus 0.
1 by 3.
Right? So this will be 0. Okay. Fine.
Understood. Yeah.
Who said the value as 16 or 1/3? Is it clear for you too?
Yeah. You know the
Yes, ma'am.
numerator 0 plus 0. When I took,
Yeah.
I assumed it to be 1. When I thought 1 is there. So, okay.
Okay, okay. You just maybe you missed one power.
Yeah, that's right. That's right.
Yeah, yeah. Okay, these are normal. No worries. But yeah, these are some just simple steps, right?
Yeah, understood. Yeah.
In
Yeah.
question, I have common as n to ma'am. I have taken common.
N cube or n square.
Sorry, n square I have taken common, so I got.
Yeah, this is also fine, no problem. You can take n square. Then in the above part, you will find something finite number, and in the below part, there will be one n still, right?
Infinity. Yes.
Yeah. So this below part will be tending to infinity, and in above we will get some finite number. So some finite number by infinity, it will be again tending to 0. This is also correct. Clear?
Yes, ma'am. Okay.
Okay. Okay. One next example. Calculate the limit for this point. E power n by 1 plus e power n. Where's the value coming?
1.
Okay, 1. Any other? So all of you are saying 1. Is it 1 according to all of you?
Ma'am, what is e power infinity, ma'am?
Infinity. That means the graph of exponential function, na, when x goes to infinity, the exponential function is also going to infinity, right? So, okay, let us solve. So we have to
It's 1.
calculate.
It's 1.
Okay, so
Now, this could
all
be
of you are saying
determinable.
what?
I mean, not determinable.
No, it's determinable. Yeah, you
Because
can determine the limit.
what we get is infinity by infinity, isn't it?
Yeah. So what did I say? That if you are in some infinity, just try to take some factor as common. Not necessarily, I mean, it should may not be some power of n. It may be exponential function. It
Okay.
may be e power n. Okay.
Oh, okay.
Here we will take common e power n.
Okay. I didn't do that. Okay.
Hmm. So if we take e power n as common, then we will get 1 over e power n plus 1, right? Then this will be cancelled out. So this term is going to infinity. That means this term will be going to 0. So we will get 1 plus 0 plus 1, which is 1. Okay?
Yeah, understood.
Okay.
Very aggressive intuition, but ma'am, I don't go with this. I mean, I didn't thought of this all things. I just made as assumption that e raised to infinity is infinity. 1 plus e raised to infinity is also infinity. So that's why infinity by infinity equal to 1.
Same, ma'am.
Oh,
For
no,
all
no, no,
questions,
no.
do we
This
need to take common?
no. This cannot. I mean, this is what it is really wrong. You cannot cancel infinity with infinity because you can cancel 2 with 2, but infinity is nothing defined. I mean, infinity is infinity.
They
Infinity
might be
plus
as
1 is
different
also infinity.
numbers, right?
This one we should
What?
go with these all steps, but we don't think about these all steps. Just got this.
No. You cannot do this
But
because
you would have got,
if
he would have got the
you are
marks.
doing this, then for the first example also the answer should be 1, right?
Yeah.
But this is not the case. This is by chance the answer is like answer became 1, but this is not the case. You can never cancel infinity with infinity. Infinity is nothing specific. It is not of specific value. So
Ma'am, do we need to take for every question? Do we need to comment these things?
yes, if you are getting infinity by infinity type of thing, or something like something problematic, then always try to take some factor as common and cancel them out so that you can get some finite. But if after doing all this step, if you are not getting something common, just for example, f of n equals to n square. Okay, so in this, or n cube by n, okay, or like f of n equals n cube by n. So if you even cancel them out, still n square will be there, right? So in that case, you don't have anything to do. In that case, the sequence will be divergent. But if you can cancel some term out, and after cancel, if you can get in, this is the limit. Okay, and never do this type of thing that infinity and infinity cancel. You cannot do this type of thing. Okay.
Because we are getting answers. So
No.
just
This
thought
is
about
this is answer by chance. This is not like this is not the process, no? This is answer by chance. So the answer may not be 1. You may get many this type of function where you will get something infinity by infinity, but the answer is something different. For just consider the first example. The answer was 5 by 3, right? There also you were getting infinity by infinity. So we cannot cancel infinity by infinity, infinity with infinity.
But
Never.
I have a question. 1 by
Yes.
infinity is 0. We consider it as 0, right?
Yes.
So in this case, n cube by n, if you if you divide the numerator and denominator by n cube, what we will have is 1 by n square, isn't it?
How?
I mean, if we divide the numerator and the denominator by n cube, so
Okay.
we'll have 1
So we will
by,
get n cube by n cube, n by n cube, right?
yeah.
So then we can cancel them out, and this will be this.
No,
So
before cancelling, if we make that as 1, the top one will be 1, and the
Yes.
numerator, the denominator will be 1 by n square.
Yes. 1 by n square. Yeah.
And 1 by n square is as good as 0.
0. So we will get 1 by 0. This is going to
Yeah,
answer.
and so it will be, so it will be indeterminable, and so you're calling
Yeah.
it as divergent, right?
Yeah. Yes. Yes. Yes.
Okay, all right. Okay, thank you.
So because 0 is, if you like, 0 is like, if you take some really small number which is close to 0, then 1 by this number will be a really big type of thing, right? So 1 by
Yeah,
exactly 0 will be infinity, which is not determined. I mean, defined.
yeah.
Okay. Yeah.
But mathematically, like infinity and indeterminable are different, isn't it? Like indeterminable
Yeah.
is like we
Yes.
can,
Yes.
yeah.
Actually,
Okay.
there are so many points of view, and there are so many ambiguity with this thing. I mean, not ambiguity, but there are so many points of view in the field of mathematics. In some cases, we used to take the infinity as a point, and then we said it like we demand the infinity as a point, and we work with this infinity. But in some case we didn't take it something fine I mean defined. Okay, so in
Okay.
your
Okay.
case, in this portion, we will not take infinity as defined. Okay.
Okay. Okay.
Yeah. Yeah.
Understood.
So
Okay.
infinity is undefined here. You just have to remind that infinity is undefined.
Okay.
1 by 0.
But there are some field of mathematics where infinity is a particular point.
Ma'am, 1 by 0 is undefined, not infinity. Because once Alak sir said that there is a difference between infinity and 1 by and undefined. He said that 1 by 0 is undefined, not infinity.
That is what I am saying. I mean, you can take it as undefined, you can take it as infinity. So there are two different point of view. If you are taking infinity as something defined, then you cannot say it as defined. Okay. This is undefined. 1 by 0 is undefined because I am taking infinity here as undefined. I am considering infinity as undefined. That is what I am saying. 1 by 0 is something infinity, like infinity. Okay. This is true that 1 by 0 is undefined. This is not infinity. But when this is not infinity, when we are considering infinity as something defined. Here I am considering infinity as not defined. That is why I'm saying it infinity. Okay. No, do any type of ambiguity. Just take it normally. This is undefined, so it is not convergent. That means the sequence is divergent. Okay.
Yes,
Okay.
Okay. Yeah, any other doubts regarding limit type of thing? Okay. I think these were the only concept covered in your week 7 portion, right? Was there anything else than that?
we'll be having one more session for the summary session, no?
Yeah. Yes. One more session is there for the open. In that session, we will cover the problems.
Okay, ma'am. As I've
Yeah.
just studied till week 6.
Okay. So these were the main concept. I think you are at least a little bit clear with the concept right now. So just look at the videos, just go through the videos, and then join the open session so that you can clear your doubts regarding the questions. Yes,
Yep.
this type of question of limit will come in the exam also. These are exam important from the exam point of view too. I solved 3 questions all the 3 questions are really important from your exam point of view. Okay. Okay, so I guess these were the portion of your week 7 content. If you have still any doubt, you can ask. Otherwise, you can leave. For any, it may be a silly doubt. Still, don't hesitate to ask it. Okay.
You teach offline in IIT Madras?
No.
Thank you for the session. Thank you.
Yeah, welcome.
Okay. Thank you, ma'am.
Thank you,
Yeah,
ma'am.
welcome.
We are leaving.
Thank you. Thank you very much for the session. Thanks a lot. Good night, everyone.
No, you don't need too much to practice. Just focus on this type of problem only. Okay. So this type of problem that you can consider as a model problem for your exams too. So if you can, okay, it is not an issue. I mean, these things are not that difficult. Okay. Bhumi, I'm saying to you, these things are not that difficult. If you are finding it like little bit tricky, then I will recommend you just solve all the activity questions and practice question. You will be more comfortable with these things. Okay. So just 2 to 3 steps you have to keep in mind. Okay. Don't be worried
Yeah,
about
sure.
it. Yeah. Just don't be worried about it. These things are not that difficult, and you will get similar type of question during exams too. Okay.
Samantha, I have a request with regard to that TA this thing. I think I discussed with you with regard to TA session schedule. Kindly ask them to stick on to the schedule instead of not canceling the sessions.
Yeah. I will ask.
And
Yes.
I
Sure.
I hope that with regard to DA, I mean graded assignment solutions also, I hope it's up to date because I need to check just a minute because I found with other subject that it's lacking. We don't have the graded assignment solution till date.
Okay. So you should get the written version, na? The graded assignment solution.
Yeah, that's what I'm. Yeah, see
Yeah.
here only up to week 3 it's available now.
Okay. So after that, you didn't get the graded assignment solution.
Yeah, because where they almost deposit in the supplementary section, am I right? In the supplementary
Okay. Yeah.
session there, when I checked, it's only up to week 3 it's available.
Okay. I will.
Kindly
Four
update that
actually.
also.
Okay, I will talk to my team about it so
Yeah,
that we
please.
can release the graded assignment
Yeah,
solution fast
yeah.
as possible.
Thank you so much. Thanks a lot.
Welcome.
Good night. Bye.
Yeah, good night.
Thank you for the session, ma'am.
Yeah, welcome. Okay, good night, everyone. So let's meet at the next session, the open session. Then we will solve more problems. Okay. Okay. Bye.